Well, hello. Can you hear me? Yeah. Okay. So my name is Szymon. I've been coding in PHP since my teens, and for 4 years I've been doing it for a living. You may find me on Twitter, GitHub, Medium, and so on by the nickname SSKORC. I come from Poland, and I live in this beautiful city of Gdańsk, where I work for Schibsted Tech Polska. This is part of the Schibsted Media Group, the largest media house in Scandinavia. Is here anyone from Sweden or Norway by any chance? What a shame. Anyway, in Schibsted Tech Polska, beside the fact that I write some code in PHP, I use Docker on a daily basis for development and deployment of web applications. I've been using it for 1.5 years now, and during this time I worked out my very own set of best practices to deal with Docker that I'd like to share with you today. And of course, for those of you who are not familiar with Docker, I'll try to provide some basic set of information, what is it and why to use it. Therefore, could you please raise your hands, those who know what Docker is? Okay, quite a lot, almost everyone. And who of you use Docker? Okay, several. And who of you use Docker on production? Oh, nearly nobody. Okay, 4 hands up. Cool. Okay, let's start with the question, what makes Docker so good? What makes it so interesting to spend time on this fantastic conference to talk about it? And those of you who don't know Docker, please treat this part as a what is Docker part. Well, a little bit of history of transports and logistics at the beginning. The introduction of intermodal containers, like these, has revolutionized the cargo transport. Containers can be used across different modes of transport, from ship to rail to truck, without unloading and reloading their cargo. The same idea stands behind Docker. With Docker, you create a virtual container with an application and its dependencies once, and you can run it on any Linux instance. I mean, your laptop, your local server, public or private cloud. It means that if you only want, your local development environment can be exactly the same as the production environment. Of course, you can easily share the environment configuration with your teammates so that all your team members can have exactly the same local development environment. And of course, setting up the environment for a new guy in the team is fast and easy. What's more, Docker uses resources isolation features of the Linux kernel, such as C groups or kernel namespaces, so that every container run within a single Linux instance is independent and isolated from both other containers as well as the host machine. It means that you can maintain different development or production environments on one machine without a hassle. For example, you can run different PHP versions, different web servers or databases without risk that one tool will spoil something in another tool or the host machine. You may say that things I mentioned, those were portability and isolation, can be achieved with Vagrant and provisioning tools like Puppet, Chef, or Ansible. Well, yes, they can. But one of the most important drawbacks of Vagrant, or virtual machines generally, is that they are heavy and often slow, like a road laurel. Docker containers do not include a separate operating system, like virtual machines do. Instead, they all share the same Linux kernel, and in consequence, the performance of Docker containers is nearly identical to bare metal. What's more, Docker images have layer structure, are cached, and can be easily shared, what makes provisioning much faster than with Puppet, Chef, or Ansible. Another cool idea of Docker. In Docker, you can run only one process on a container. It means that each part of your stack, like a web server or a database, should be run in a separate container. In fact, you can create your Docker environment using different linked together containers, the same way you build something with Lego bricks. What's more, Docker provides the service called Docker Hub. It is the ultimate source of Docker images. There are 86 official images for different tools like web servers, databases, or different PHP versions, as well as thousands of unofficial images created by the community. If you want to test out some framework or tool, it's highly probable that there has been some image with it, and it can be easily tried out. You don't need to worry how to install or configure some particular tool. All you need to do is to find an image with it on Docker Hub, download it, and run it. Before we move on, let me give you one short explanation about the difference between images and containers, because these two words have been mentioned by me already a few times. In brief, the difference between them is similar to the difference between a class and an object in object-oriented programming. An image is a kind of a model based on which containers are made. Containers are instances of images. Okay, then. Let's move to the question how to use Docker to develop PHP applications. I will answer this by explaining two different use cases. But before we move to the first use case, one important information. Docker engine can be run only on Linux. Fun fact about Windows is that Microsoft has spent quite a lot of money in Docker development, and in consequence, Windows Server 2016 is going to have its own Docker engine implementation. It means that we will be able to create Windows-based containers and run them on Windows. Anyway, let's stick to Linux, since this is the most common use case in web development. If you want to run Linux-based Docker containers on Mac or Windows, you need a virtual machine with Linux and Docker engine installed. Fortunately, Docker created a very cozy tool called Docker Machine. The tool creates transparent virtual machine with Docker engine on non-Linux operating systems, I mean Windows and Mac. It works like this. On your host, and this is Mac or Windows, you have some Docker client. The standard one is Docker CLE. You also have a virtual machine with some Ubuntu being run on some hypervisor. The standard one is VirtualBox. On this virtual machine, you have Docker engine installed. All your containers are being run on this virtual machine. Because of the fact that on Mac and Windows, you need a virtual machine, the runtime performance is not a lot better than when using Vagrant. However, at least creating, starting, and stopping containers is much faster than starting and stopping virtual machines. Okay, let's take a look how using Docker machine works in practice. So I have a demo for this. First, we need to create a machine or start it if we have one. I've already created a machine to use in the demo because it takes some time to create it. So we can start it by typing Docker machine start PHP UK. This is the name of the machine we use in this case. So it takes a couple of seconds to start the machine. Yeah, the machine has been started. So as we can see in the instruction, it's recommended to run Docker machine env command followed by the name of the machine. The purpose of this command is to print the command we should copy paste in the console to make it communicate with this machine. So we can type Docker machine env and the name, so PHP UK. Okay, so we are being instructed to run the same as before, but this time with evil. This command on Windows would be different. So we can copy paste it and run it. Yeah, and our console is ready to communicate with Docker machine. We can prove it by typing docker info command. So we can see information about our Docker and Docker engine. So we are ready to start playing with Docker, but there is another step, useful step to follow. If we are developing some heavy PHP applications, and by this I mean almost any modern PHP framework with a lot of dependencies, it's recommended to change default sharing, file sharing type from native VirtualBox to NFS. And we can easily deal with it by using third-party tool, which is called Docker Machine NFS. All we need to do is to download it from GitHub, install, and in consequence, we will have Docker Machine NFS command in our console, and we can run it. So all we need to do is to type Docker Machine NFS, followed by the name of the machine. Yeah, and this is it. So we can enjoy high-speed mounts. This is it about Docker Machine. Let's take a look how it can be used. So let's move to the first use case where Docker shows its strength. I have a question. How many of you guys have already tested new PHP 7? OK, not that many. Cool. A friend of mine has recently asked me a question. Well, I have few projects in PHP 5, and I'd like to test PHP 7. And how to do this? How to install PHP 7 and don't spoil PHP 5? As we all know, running 2 PHP versions at once on one machine can be a hassle. So I said to my friend, find PHP 7 image on Docker Hub, download it, and play it. He said he wouldn't like to use Docker because he had no experience with it, and he had it's hard. And I said, well, it isn't really. And I showed him this. Assuming you have Docker ecosystem installed, and this is pretty easy. All you need to do is to follow tutorial on Docker website. You need to pull PHP 7s from Docker Hub. And you can do it by running docker pull command followed by the name. And this is php:7. This image is being pulled from the Docker Hub, from the internet. I have this image pulled already, so it didn't take much time. Then we can run our PHP 7 script on it. And maybe let's try how the new spaceship operator works. So I have a script that uses this new spaceship operator. Let's take a look. And it uses spaceship operator in the if statement. So it will print its PHP 7 if this spaceship operator works. And it should print syntax error if it doesn't. So let's start our container. To run this script, we need to run the container. And we do this by using docker run command. So we run we type docker run with some parameters. So the 2 standard ones are IT. And these are for interactive processes, basically. T pretends container to be TTY, and I is to keep std and open. Doesn't really matter. You just need to type them. Then some another parameters. So it's useful, and it's necessary to share the script we have with the container. So we do this by setting up a volume, and we do this by using v parameter. So in this case, we set first we set the place on our host we'd like to share with the container. And since we cannot, we have to use full path, we can't simply type dot, we can type pwd. And then, after a colon, we set the place on the container we'd like to have these files. So it can be some user directory. Another parameter it's not necessary, but it's useful, is setting the work directory. It is the directory in the container on which all commands will be run by default. So we can type, we set it by typing w parameter, and the value can be the same place we have our files on the container. OK. And Then we should also set two necessary things. So the first one will be the name of the image based on which we'd like to run our container. So this is PHP in version 7. So we type PHP:7. And then we need to type the command we'd like to run on the container. So it will be running this script. So it will be php test.php. And then we can run it. Yeah, it worked. It simply printed its PHP 7. With Docker, we can even very easily prove it doesn't work on PHP 5. So all we need to do is to run the same command, but change one digit from 7 to 5. So we can copy-paste it and change this 7 to 5 actually, and run it again. Yeah, and we can see that space operator doesn't work. It prints syntax error. All right. Let's move to some more complicated stuff. Let's try to run complete PHP application on Docker. So let's think about a standard environment to run some PHP application. This is kind of a variation of a LAMP stack. So we need a web server. It will be Nginx in this case. We need an interpreter. It will be PHP FPM in this case. And we need a database. It will be MongoDB in this case. All three of these tools are separate processes, what means that each one of these is a separate Docker container. The end user is going to communicate with the web server, what means the Nginx container. This container is connected with PHP FPM container, where we run our application. And this one is connected with the database. PHP FPM and Nginx containers share application sources with the host. This is because in the development environment, we keep our sources on the host. On the host, we have IDE and Git, etc. MongoDB shares database files with the host, and this is because we want to have these files persistent. I mean, we want to have data in MongoDB persistent. Docker containers are not persistent at all. I mean, if we destroy container, its content disappears. So we need to have our files, our data persistent, we need to share the database files with the host. Docker created a tool which is called Docker Compose, and thanks to it, we can configure our whole environment in one YML file. So line by line. On the highest level, we define containers in our environment. In this case, these are three containers with names PHP, Nginx, and DB for MongoDB. And for the PHP container, we define that it's being built from the Docker file that is in our work directory. What is a Docker file? I'll explain in a minute. Then we said that it's linked to DB container, and it shares application sources with the host. So on the left, we set the place on the host we have our files, and then on the right, we define the place on the container to put these files, and this is standard web server directory, directory for web server files. Then, in the Nginx container, we define that it's being built from the image that is on Docker Hub, and it has name Nginx, and it is in version 1.9.10. It's linked to PHP container. It shares the same file, so it has the same volume as PHP. And additionally, it has its own volume, and this one is to share a virtual host configuration file. Finally, we said that it should expose its AT port. And in the DB container, we define that it's being built from the image on Docker Hub that's named Mongo, and it's version 3.2.1. It shares those database files with the host, and it exposes its 27017 port. This is standard MongoDB port. I've mentioned that the PHP container is being built from the Docker file. So what is the Docker file? In this file, we keep instructions based on which the Docker image is being created. And based on this Docker image, we run our container. So line by line. First, we tell based on which image we'd like to build our own image. As I said before, Docker images have layered structure. So that we can easily build an image based on another image. In this case, we use official PHP FPM image as a base for our particular image dedicated to this project. Then we install libraries and tools we need. So we install Git. Since this is a Symfony application, we need APC and internationalization libraries. So these are simple apt-get install or PCL install instructions. Then we install Composer. It's pretty simple. And finally, we copy the PHP ini file for this particular project, and then we set the work directory. All these lines, except 2 last lines, are necessary to run any Symfony application based on Mongo, and they are generic. So we can move this long part to a separate generic Symfony image, and I did it. So in this case, I created my own image named Symfony to Mongo, which I pushed to Docker Hub. In Dockerfile, for this particular project, I left these lines that are specific for this project, and I replaced that long generic part with one simple statement saying that we'd like to build this particular image based on my generic Symfony and MongoDB image. When we have such a configuration, all we need to do is to type docker compose up-d command. The D parameter means that containers will be in the detach mode, so they will be run in the background. So let's take a look how it works in practice. We have Docker machine up and running. We did it before, so we can run our environment. But before we do this, let's first add the virtual host to our local's etc hosts file, and so that we will be able to access the app. We need to find out Docker machine's IP address, and we can do it by typing Docker machine IP command followed by the name. So this is PHP UK. Yep, and we can see the address, IP address of this machine. We can copy it together with the virtual host name to our etc hosts file. And I guess I have done it already, so let's check this, and we can simply grab our etc host file with the name of the virtual host, and this is Docker Symfony in this case. Docker Symfony.dev. Yeah, we have it. So if we have it, we can run our environment. So we can run that docker compose up-d command. Yeah, that's it. Our containers has been started. They have been had been already created before, so it didn't took much time. If they weren't created, the Docker Compose would download images, these 2 images for Nginx and MongoDB from Docker Hub, and it would build the image, our particular image for PHP. So the environment is up. We can see which containers are up. So we can type docker ps command. And we can see that we have 3 containers up and running. And we can start using our application. So let's type its virtual host name to the browser. This is a simple to-do list application. So it has some tasks, and we can add another task, and let it be drink during tonight's party, and add it. Yep, and it works. So this is it. This is how it works in practice. This is it about the development, but what about the deployment? One of the most important advantages of Docker is that you can use identical or nearly identical configuration to run an environment both on a local development environment and in the production. I'll show you how to deploy that PHP application into the cloud using Docker. There are different services that let you run Docker environment in the cloud, and these are some of those. So Amazon Web Services supports Docker in Elastic Beanstalk. you can define your containers in a JSON file that has a structure similar to Docker Compose YML file. On AWS, there's also EC2 container service, but its configuration is not particularly easy. Since last August, Docker Heroku has been supporting Docker environments, but it's limited to Heroku's images only. So you can use only these images that are created by Heroku. Docker has its own service, and it's called Tutum. And it lets you run Docker containers on different infrastructure as a service providers. Docker Machine supports creating virtual machines with Docker not only on your local development, on your local machine, but also in the cloud. And by this I mean DigitalOcean's cloud. And if we would like to run Docker containers or any infrastructure as a service provider or on our own machine, it may be a good idea to use CoreOS. This is the Linux distribution dedicated to running Linux containers, including Docker containers. In this presentation, I'll show you how to use Tutum to deploy Docker into the cloud because some of particular reasons. First, Tutum is an official Docker service. It has been acquired by Docker a few months ago. Second, it allows to run Docker containers on a number of different infrastructure as a service providers. Third, it's pretty easy to understand its basic concepts and run your first environment. And last, it's free, at least during beta testing period. What is Tutum? Tutum is a type of platform as a service solution, and it doesn't have its own infrastructure. So to use it, you have to have an account on one of these 5 infrastructure as a service providers, or you can always configure your own machine to integrate with Tutum. Once you log in into Tutum, you will be walked through the system by the very useful tutorial. First, you have to connect your account with one of those 5 cloud providers. I tried it with Amazon Web Services, and it was pretty simple. All I needed to do was to copy 2 keys I found in my AWS credentials. Next, you need to create a node cluster on a given cloud provider. Actually, the only thing you need to set is the name of the cluster. All the rest can be default, and Tutum will do all the work for you. So it takes a couple of minutes to create a node cluster. And once it's created, you will see it in your node dashboard. You can see its status and details, and you can easily terminate it anytime. On a node cluster, you can run one service or a couple of services, and this is called a stack. A service is a set of similar containers, created from the same image. In our case, we have 3 services. These are Nginx, PHP, and MongoDB. You can define a stack of those using graphical user interface, but I think it's more convenient to do this by a stack file. It is a file that is very similar to Docker Compose YML file. There are only some small differences between them. And if you have it, you can paste it in the browser or push it to Tutum using either its REST API or Tutum's CLE. So this is a stack file. So I've created my stack file based on my Docker Compose YML file. There are only some small differences between these 2 files. So first, I don't build an image ad hoc, but I assume it's already built and available on Docker Hub. Second, I don't share application sources with the host machine, but I assume that these sources are in the image. However, I create a volume to be able to share these sources with the Nginx container, since these 2 containers need these files. And then I change the host path of Nginx configuration file and database files. Well, once you create your stack, it's being deployed to your node cluster. You can see its status in the stack dashboard. And using it, you can stop, terminate, or redeploy the whole stack or one particular service. If you want to start using the stack, you need to find the endpoints URLs. In this case, we're interested in the Nginx service URL. And if we click the link, we'll see our application up and running. When I showed you the stack file, I said that I assumed that the image for the PHP container has been already built, and it has some application sources, and it's available on Docker Hub. Well, first you need to build it and push it there. But you can leave it to Docker Hub to do it by itself thanks to its automated builds feature. So you can make that a particular image on Docker Hub will watch changes on GitHub repo, and it will rebuild the image after every change in some particular branch, let's say master branch. They can also set a webhook in Docker Hub to automatically redeploy the service in Tutum once the image is rebuilt. To have the application sources bundled with the image, we need to make some small changes in our Docker file. So what we need to do is to add these two lines. First one adds application sources to the image, and second one runs composer install to download all dependencies. In the setup I described, the whole continuous delivery process looks like this. We keep our sources on GitHub. After any change in the master branch, we run images redeploy on Docker Hub. Once it's done, we trigger the service redeploy on Tutum, and it populates it on our node cluster. This process is good enough, but it lacks one important step. What should be done before we actually start a deployment? Any guesses? Tests, perfect. We should run tests. So, since we cannot run tests on Docker Hub, we need to do a small change in this part and add some continuous integration service to our process. This can be Travis CI because it's been supporting Docker since last summer. So, with this change, it is the Travis CI that rebuilds the image after a change in the repo. Then, it pulls other images, for example, MongoDB image, starts the environment using Docker Compose, and then it runs tests on it. If tests go right, we can push our already rebuilt image to the Docker Hub. We don't build anything on Docker Hub anymore, and we use it only to store our image. Also, we don't use Docker Hub webhooks to trigger the deploy. Instead, we use Tutum's API, REST API call to redeploy the service so that we can add some additional parameters and that we can have a better control over the redeploy process. You may ask me how to configure Travis to build the image, run the environment, and push changes to the repo, to Docker Hub. Well, you place the whole configuration in Travis YML file. So line by line. First, we set the environment language. We can leave default Ruby value. We don't want to set PHP because we want to prevent Travis from installing Composer dependencies on the build's host machine. We also need to tell Travis to use Docker. Then, we need to log into Docker Hub. So we can use Docker login command followed by our credentials. These are email, username, and password, and these can be hidden behind environment variables. And we should also remove Symfony's development files. The core of the build is to build an image, then run the environment with Docker Compose, and then run tests. So we have two jobs to run specs and do some static code analysis. Finally, if the build is on master branch and it's successful, we can deploy it. We use custom script provider, so we need to keep our deployment command in one shell script. And we have three deployment commands. So first, we tag our image with the Travis build number, so that we have the history of images. Then we push it to the Docker Hub. And finally, we call a service redeploy request to Tutum. So this is some CRL call with some JSON parameter. After the build is done, we can see if it has been deployed in the service timeline in Tutum. Well, this is it about deployment. Let's talk about threats or maybe some disadvantages of Docker. Docker, as every technology, is not perfect enough. It has some limitations and threats that you should be aware of if you want to adopt it. My personal experience with Docker is that in the past, there have been more disadvantages and problems with it. But it seems that the products team really listens to its users, and they do their best to deal with issues. It's very probable that things I'm going to say about won't be valid in the nearest future. So what are the most important threats of Docker for me right now? First, there is a problem with garbage collection. Docker doesn't remove unused containers and images from your system, what can lead to running out of disk space after some time. There is a number of workarounds. For example, you can have a cron job that will remove unused or old images and containers from time to time. You can also delete them, for example, with every deploy. You can always use some of advanced third-party tools that deal with this common problem. There is a number of different tools on GitHub that deals with that. Second, you need to remember that containers are not persistent at all. This means that you basically cannot rely on writing to disk files that aren't shared with the host. So primarily, this affects any database files, session files, logs, or user-generated files like uploaded files. Of course, you can always rely on shared volumes, so share these files with the host, or you can use external services like Amazon RDS or S3. Third, it seems that Docker's web services like Docker Hub aren't stable enough yet. I mean, although the uptime of Docker Hub is good enough, it's pretty good, you may meet its downtime during your work hours much often than it happens with GitHub or Travis. And last, Docker is still young technology. It changes a lot, and it hasn't been widely adopted yet. So it means that if you want to use Docker in production, you will need to accept that you will either use technologies that are in beta testing period, like Tutum, or that have some limitations, like Amazon Elastic Beanstalk or Heroku. Or you can always face some pioneers issues and configure your own server to run Docker. We are heading to the end. So here's the place for some wrap-up. If I was asked to answer the question, should you try Docker in one short sentence, I would say, yes, you should. And why? Well, there is a couple of reasons. First, portability. You can run Docker container on any Linux instance, on your laptop, your local server, public or private cloud. It means that if you only want, your local development environment can be exactly the same as the production environment. What's more, you can easily share the environment configuration with your teammates. Second, isolation. Every container run within a single Linux instance is independent and isolated from both other containers as well as the host. Third, performance. Docker containers do not include a separate operating system, like virtual machines do. Instead, they all share the same Linux kernel, and in consequence, the performance of Docker containers is nearly identical to bare metal. Fourth, modularity. In Docker, any part of a technology stack, like a web server or database, is a separate container. In fact, you can create your Docker environment using different linked-together containers the same way you build something with Lego bricks. And fifth, community. The popularity of Docker is growing at an enormous pace. On Docker Hub, there are 86 official images for different tools and thousands of unofficial images created by the community. What's more, there are more than 50,000 of repos on GitHub that are connected to Docker somehow, with, for example, sample Docker Compose configurations or additional tools to Docker machine. I hope that this presentation encouraged you to give Docker a try if you haven't done it yet. And if you've been already using Docker, I hope that I gave you a good overview of how it can be used to develop and deploy PHP applications. On GitHub, you will find sources of the application we used in the demo, together with Docker configuration. On Shipstead Tech Polska blog, you will find some posts, including my posts about Docker. For example, how we used it to develop and deploy our company's site. Please, please, please rate my talk on Joinden. And if you have any questions, you can ask them in a minute, or you can catch up with me today or tomorrow, or you can always find me on Twitter. Thank you very much for your attention.
Szymon, thank you very much. So we do indeed have some time for questions, both from this room and the other. Raise a hand. Aaron, I'll hand you a mic.
It's per container, but for example, for a web application that I'd run, I'd have maybe a CLI and the FPM process, and then maybe have cron running that. So how would you recommend to set that up?
So actually, there are two possible ways, or three actually. You can multiply your containers, and on one you will run PHP FPM together and the container. Since you have PHP FPM, it's not possible. So there are two ways, I would say. The way I use it is that with Docker in version 1.5, since this version, you can run Docker exec command. So this is running some command on an existing container, and it doesn't spoil the command that's already in the image. So you simply can type Docker exec with cron. The second possible solution is to run supervisor as a process, and then you can have multiple other processes running on a container.
Okay, so you are, in some circumstances, allowed to have multiple processes within a container. I mean, say allowed, but it's a best practice.
Yeah, it's allowed, but the best practice is to have only one process on a container.
Okay, thank you.
Any more questions?
But we've got dead mics, so hang on a second.
You were saying about running on bare metal. Would you recommend if you actually say you're creating your own host, could you have the Docker running on a VM? You know, if it's preferred to use that as what would be your bare metal server. So effectively, you've got Docker on a VM on bare metal.
What is the best solution for the VM, right?
No, just as that. Would you say that's an acceptable infrastructure, or would you say that actually you should not be having a VM underneath Docker? You should be saying, okay, let's have Docker on bare metal.
If you want to run Docker on bare metal, you have to have a Linux instance, basically.
But for example, say we've got a cloud provider. I want to try Docker. Obviously, I don't use bare metal. I only use virtual machines. So I'm going to use a virtual machine and then run Docker within that. Is that would you say?
Okay. So you run Docker in this virtual machine, but you don't share these files with the host that's the host of the virtual machine. So then the performance is the same. Like it doesn't matter.
Okay. Thank you.
There's a question in there.
Okay.
Okay, the idea was, could you use Docker, how would you use Docker to put a PHP 7 interpreter at the command line, similarly to the way you made it run a single script, but to actually get the command line interpreter available from,
Basically you won't type the name of the script you want. So it will be PHP basically, and I don't know, I haven't used PHP like the command line
as a
CLI a lot, but I don't know, if you have a standard configuration, if you type PHP, it will allow you to write something within. You have to add some additional parameter. -A. Okay, yeah. So if you type PHP -A, it will work.
PHP-A. Thank you.
But you have to remember about these two parameters for Docker run. These are IT, so to have interactive process.
Another question here?
Yeah.
So another question?
Yeah, this is very like.
Experimental is what you're going to say?
We have good information from the audience. We can type bash and then we can play with Docker, and this is like the standard way to do anything on a container. You just simply run docker it followed by the name of the container, then you type bash, and then you can play with Docker container. You can do anything on it.
You were showing images on Docker Hub,
yeah.
And you said that there are like thousands of them. Is it possible to have private images?
Yeah, yeah. This is how we roll. So you can have private images connected to private GitHub repo, or that you push without repo, and you can have teams in Docker Hub, so you can set this image is visible only for you or for your team, but it's not free. You have to pay for it. It's pretty cheap, as far as I remember, a couple of dollars. And you can also, there's a possibility that you keep your images not on a Docker Hub, but some other repositories. So there are different repositories that you can run either on-premise or on demand. But the Docker Hub is the standard one.
Hi, the question I have is, where do you keep passwords and other credentials in terms of Docker containers? Do you put them inside or outside, or how do you manage that?
In our practice, in production environment, we keep those in Docker container.
Any more? Yes.
How do you deal with the case where you have containers running across different services? So let's say you want to have some services running on Amazon, some on DigitalOcean, for example. So is there a way to link those together?
As far as I know, there is no way. Maybe there is some way, but I haven't faced this issue.
Okay.
So I cannot tell.
Well, they're all smiling. So I don't think there's more questions. Oh, yes, we do. Yeah.
How does Docker support failover clustering?
Once again? To be honest, in the configuration, in our cases, we have services that they don't have high traffic. However, we use Elastic Beanstalk, Amazon Elastic Beanstalk for some services, and then, for example, we have auto-scaling of 4 machines, and it can scale up to 4 machines, and then it populates Docker containers on each machine. So it works like this.
Okay, well, we might have time for a few more questions, or perhaps Szymon will hold around up here if you want to ask questions directly when you get up the front. Thank you very much for your talks. Fascinating.
Thank you very
Docker.
much.